Arumugalakshmi from Sri Jaindra Saraswati Vidyalaya Matriculation High Secondary School, Singanallur. Namaste. Today we are going to discuss about the physics problems in lesson 3 of class 11. The first problem is a force of 50 Newton act on an object of mass 20 kg as shown in the figure. Calculate the acceleration of the object in x and y direction. So let us start with the given data. Force is given as 50 Newton and mass is 20 kg. See the diagram. The force is acting at an angle theta which is given as 30 degrees. So we can resolve the force into two components, x component and y component. So first the component of force along x direction we will find, which is Fx is equal to F cos theta. So F value is given as 50 Newton, theta value is given as 30. So substitute in this equation. So Fx is equal to 50 into cos 30, which is equal to 50 into root 3 by 2. So the answer is 43.3 Newton. We are supposed to find the acceleration. So we use the formula F is equal to ma, your Newton's second law. So from that equation, acceleration is equal to F by m. So F value we have found it as 43.30 divided by mass is 20. So the acceleration is 2.165 meter per second square. Now the component of force along y direction, which is given by Fy is equal to F sin theta. The value of F and theta substitute in this equation. So Fy is equal to 50 into sin 30, which is 1 by 2. So 50 into 1 by 2, which is equal to 25 Newton. Now we will find the acceleration along y-axis using the formula Ay is equal to Fy divided by m. So substitute the Fy value and m value, which is 25 divided by 20, which is equal to 1.25 meter per second square. So the acceleration along x-axis is 2.165 meter per second square and the acceleration along y-axis is 1.25 meter per second square. Now the second problem. A spider of mass 50 gram is hanging on a string of a cobweb as shown in the figure. What is the tension in the string? So the given data is mass is equal to 50 gram. We are supposed to find the tension. The formula for tension in the string T is given by T is equal to M into G, whose M value is 50 gram and G value is acceleration due to gravity, which is 9.8 meter per second square. So substituting in this equation we get T is equal to 50 into 10 power minus 2, where we have converted gram into kilogram into 9.8. So the answer is 0.49 Newton. So the tension in the string is given by 0.49 Newton. The third problem is, what is the reading shown in the spring balance? First diagram. Here, when a spring balance hung on a rigid support and a load is attached at its other end, the weight of the load exerts a force on the rigid support. In turn, the support exerts equal and opposite force on that load, so that balance will be stretched. This is the principle of spring balance, and hence here the two sides of the spring balance is balanced by the 4 kg. Hence the reading on the spring balance will be 4 kg. Second one, the mass is given as 2 kg and the angle theta is given as 30 degree and it is hung on a rigid support and the load is attached at its other end. The weight of the load exerts a force on the rigid. Hence, we resolve the weight into its components as mg sin theta and mg cos theta. Here, if you see the diagram, this mg sin theta acts parallel to the surface and is balanced by the weight. And hence, weight is given by mg sin theta. Now, substitute the m value and theta value from the given. Hence, we get weight is equal to 2 into 9.8 into sin 30, which is equal to 2 into 9.8 into 1 by 2, which is given as 9.8 Newton. The fourth problem, a bob attached to the string oscillates back and forth. Resolve the forces acting on the bob into components. What is the acceleration experienced by the bob at an angle theta? The given gravitational force mg is acting downward and it can be resolved into the two components as mg cos theta and mg sin theta. T is the tension exerted by the string. So the tangential force F suffix T is given by m into at, which is balanced by the mg sin theta component. And hence the tangential acceleration is given by A is equal to g sin theta. And the centripetal force is given by Fc is equal to ma, which is equal to T minus mg cos theta. And hence acceleration is equal to T minus mg cos theta, the whole divided by m. So, the acceleration experienced by the bob at an angle theta is T minus mg cos theta, the whole divided by m. The fifth problem, two masses m1 and m2 are connected with a string passing over a frictionless pulley fixed at the corner of the table as shown in the figure. The coefficient of static friction of mass m1 with the table is mu suffix s. Calculate the minimum mass m3 that may be placed on m1 to prevent it from sliding. Check if m1 is equal to 15 kg, m2 is equal to 10 kg and m3 is equal to 25 and mu s is equal to 0.2. So let us consider m3 is the mass added on m1. So the maximal static friction is given by F max is equal to mu s into n, which is equal to mu s into n is given by m1 plus m3 into g. Hence, the tension acting on the string is equal to T is equal to m2g. So, these two equations we are going to equate. So, mu s into m1 plus m3, which is equal to m2g. So, here in this equation, we are taking the mu s inside. So, the equation becomes mu s into m1 plus mu s into m3 is equal to m2. Now, divide the above equation by mu s on both the sides. So, the equation is m1 plus m3 is equal to m2 divided by mu s. Now, m3 is equal to m2 divided by mu minus m1. Now, the given data you have to substitute in this above equation. The given data are m1 is equal to 15 kg, m2 is equal to 10 kg, m3 is equal to 25 kg and mu s is equal to 0.2. Now, substitute these values in the above equation. So, we get m3 is equal to 10 divided by 0.2 minus 15, which is equal to 15 minus 15, which is equal to 35 kg. So, the minimum mass m3 is equal to 35 kg has to be placed on the m1 to prevent it from sliding. But here m3 is equal to 25 kg only. So, the combined masses m1 plus m3 will slide. Now problem 6. Calculate the acceleration of the bicycle of mass 25 kg as shown in the figures 1 and 2. So the given data is mass of the bicycle M is equal to 25 kg. So for figure 1, the net force acting in the forward direction is 500 minus 400, which is equal to 100 Newton. So the acceleration you can find using the Newton's second law, which is F is equal to ma. Hence acceleration is equal to F by m. So F is 100. So 100 divided by 25 is 4 meter per second square. The acceleration of the first bicycle is 4 meter per second square. Now figure 2. In figure 2, two forces 400 Newton is acting along the two direction. Hence the net force acting on the bicycle F is equal to 400 minus 400, which is equal to 0. Hence the acceleration is equal to F divided by m, which is equal to 0 divided by 25, which is ultimately equal to 0. So the acceleration of the first bicycle is 4 meter per second square. The acceleration of the second bicycle is 0. Now the seventh problem. A football player kicks a 0.8 kilogram ball and imparts it a velocity 12 meter per second. The contact between the foot and the ball is only for 1/60th of a second. Find the average kicking force. So the given data is mass of the ball is equal to 0.8 kg. Final velocity v is equal to 12 meter per second and time t is equal to 1 divided by 60 seconds. Initial velocity is 0. We know that the average kicking force is given by the formula F is equal to ma, which is equal to m into v minus u divided by t. Now substitute the m value, v value, u value and t value in this equation. We get F is equal to 0.8 into 12 minus 0 divided by 1 divided by 60. So the answer is 576, that is 0.8 into 12 into 60. The answer is 576 Newton. So the average kicking force is given by 576 Newton. Now the eighth problem. A stone of mass 2 kg is attached to a string of length 1 meter. The string can withstand maximum tension 200 Newton. What is the maximum speed that stone can have during the rolling motion? So the given data are mass of the stone is equal to 2 kg, length of the string is equal to 1 meter, maximum tension is equal to 200 Newton. Here, the force acting on the stone in a whirling motion is the centripetal force, which is provided by the tension in the string. Hence, T max is equal to F max is equal to mv squared by r, which is equal to 200 from the given data. So 200 is equal to mv squared by r. Here substitute the m value as 2 and r value as 1. So 200 is equal to 2 into v square. So v square will be equal to 200 divided by 2, which is equal to 100. So v square is equal to 100. Hence v is equal to 10 meter per second. So the maximum speed that stone can have during the whirling motion is 10 meter per second. The ninth problem. Imagine that the gravitational force between Earth and the Moon is provided by an invisible string that exists between the Moon and the Earth. What is the tension that exists in this invisible string due to Earth's centripetal force? So the given data is mass of the moon is 7.34 into 10 power 22 kilogram and the distance between the moon and the earth is 3.84 into 10 power 8 meter. So we will find the centripetal force. F is equal to mv squared by r. Substitute the mass value, r value and the v value. Hence we get F is equal to mv squared by r, which is equal to 7.34 into 10 power 22 into 1.023 into 10 power 3 the whole square, the whole divided by 3.84 into 10 power 8, which is equal to 2 into 10 power 20 Newton. Hence, the tension that exists in the invisible string due to the Earth's centripetal force is given by 2 into 10 power 20 Newton. The 10th problem. Two bodies of masses 15 kg and 10 kg are connected with light string kept on a smooth surface. A horizontal force F is equal to 500 Newton is applied to a 15 kg as shown in the figure. Calculate the tension acting in the string. So the given data are M1 is equal to 15 kg, M2 is equal to 10 kg and F is equal to 500 Newton. The tension acting in the string T is equal to M2 divided by M1 plus M2 into F. Now substitute M1, M2 and F value in the given equation. We get T is equal to 10 divided by 25 into 500, which is equal to 200 Newton. The tension acting in the string is given by 200 Newton. The 11th problem. A car takes a turn with velocity 50 meter per second on the circular road of radius of curvature 10 meter. Calculate the centrifugal force experienced by a person of mass 60 kg inside the car. The given data are mass of the person is equal to 60 kg, velocity of the car is equal to 50 meter per second, radius of curvature is equal to 10 meter. We are supposed to find the centrifugal force, which is given by F is equal to mv squared by r. Substituting the mass value, velocity value and radius of curvature, we get the value of centrifugal force F as 60 into 50 square divided by 10, which is equal to 15,000 Newton. Hence, the centrifugal force experienced by a person of mass 60 kg inside the car is 15,000 Newton. Problem. A long stick rests on the surface. A person standing 10 meters away from the stick. With what minimum speed an object of mass 0.5 kg should be thrown so that it hits the stick? Assume the coefficient of kinetic friction as 0.7. So the given data are distance s is equal to 10 meter. Mass of the object m is equal to 0.5 kg. Coefficient of kinetic friction mu is equal to 0.7. So first we have to find work done in moving the body in the horizontal surface. W is equal to mu r into s, which is equal to mu into mg into s. So this work done is equal to the initial kinetic energy of the object. So kinetic energy is given by half mv square. This half mv square is equal to the work done, which is given by mu into m into g into s. Here m is same on both the side of the equation, so we can cancel it. Hence v square is equal to 2 into mu into g into s. Now substitute the value of mu, g and s from the given data. We get v square as 2 into 0.7 into 9.8 into 10, which is equal to v square is equal to 14 into 9.8, which is equal to 137.2. So v square is equal to 137.2. Hence v is equal to 11.71 meter per second. Hence, the velocity is equal to 11.71 meter per second.